Hi guys, this is Gurneet. In today's video, we are going to learn about data science and introduction to statistics. So now coming to fundamental of statistics. Now, the most important aspect of a data science approach is how the information is processed, right? So when we talk about developing insights out of data, it is basically digging out the possibilities, right? Now, many of us wonder how how can the data which is in the form of text, images, videos, etc. get so easily processed by machine learning models, right? Now, but the reality is we convert that data into a numerical form, which into a numerical format, and with the data which is in the numerical format, it provides us with infinite possibilities to understand the information out of it, right? And statistics, it acts as a pathway, right? It acts as a pathway to understand your data, right? And it also provides methods to measure the success of our insights. Then we can get different approaches for the same problem, right? And we can also get the right mathematical approach for our data. Now, as they say that the data processing from the beginning to the end, the complete cycle is a requirement of statistics at every single step, right? So now we have 8 basic concepts which are used in data science, which are: first, understanding the data, the type of analytics; second, probability; then we have central tendency, variability, relationship between the variables, probability distribution, hypothesis testing, and statistical significance; then at last, regression. So we'll understand these concepts step by step. Coming to our first concept, which is understanding the type of analytics. So first is, we have 4 types of analytics, right? Descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. So descriptive analytics, what it does is it tells us what exactly happened in the past. So if we have a data, what descriptive analytics will do, it will find out what happened in the past history, right? And it helps business understand how it's performing, but it provides context to help stakeholders interpret the information. So to summarize, descriptive analytics is tells us exactly what happened in the past. Then we have diagnostic analytics, which is the next step ahead. So what it does is it takes the descriptive data, right, and it understands why something happened in the past, right? So this is pretty much about diagnostic analytics. Then coming to the next step, which is predictive analytics. So what a predictive analytics does is, looking at the descriptive data analytics and diagnostic analytics, it predicts what is mostly like to happen in the future, and it provides companies with the insights, actionable insights based on that information, right? Then at last, we have prescriptive analytics. Looking at these first 3 steps, which is descriptive analytics, diagnostic analytics, and predictive analytics, prescriptive analytics, what it does is it provides recommendation regarding actions that might advantage the business, and what it does is it recommends any action based on the forecast. So to summarize all 4 of the analytics, what happens is descriptive tells us what happened, diagnostic tells us why it happened, predictive helps us to forecast what might happen, then prescriptive, it recommends any action based on the forecast. So in this manner, we can understand the type of analytics. Then coming to the probability. So a probability is the measure of likelihood that an event will occur in a random experiment, right? So we have conditional probability. So conditional probability is a measure of probability that an event might occur with some relationship to one or more other events, right? So let's first understand the complement. So a complement, probability of A plus probability of A complement is 1. Now a probability is that an event might occur, right? Complement is that an event, the probability of that event which might not occur, right? So they are quite opposite to each other. Probability is that the likelihood that an event will occur, and probability of A complement is that the event might not occur. So the sum of that is 1. So that is complement, probability of A plus probability of A complement is 1. Then we have conditional probability, as I explained, that an event might occur given that it might have a relationship with the other one or more events, right? So that means probability of A by B is equal to probability of A intersection B. Intersection means probability of A multiplied by probability of B. And union is probability of A plus probability of B subtracted by the intersection of the probabilities of A and B, right? Then the probability of conditional probability is probability of intersection divided by probability of the event that occurred, given that the probability of B is greater than 0, right? Then we have independent events. So independent events are now two events are independent if the occurrence of one does not affect the other, right? So if a one particular event is occurring, it might not affect the event which is probability of another event that is occurring. So these two events are independent. So that is probability of A intersection B is probability product of probability of A and probability of B, right? Given that probability of A is not equal to 0 and probability of B is not equal to 0, right? Then we also have mutually exclusive events. So two events are mutually exclusive only if they cannot occur, like both cannot occur at the same time. One is occurring at one particular time and the second is occurring at different time. So probability of A intersection B is equals to 0, and probability of A union B is the sum of probability of A plus probability of B, right? Coming to our next slide, which is Bayes theorem. So Bayes theorem is nothing. It is a way to figure out the conditional probability, right? Now, Bayes theorem, it describes the probability of an event based on a prior knowledge of conditions that might be related to the event. So we have a prior knowledge of we have a prior probability and posterior probability. So let's understand this using an example. Now, let's say that we have a data set of patients who have liver disease. So probability of A would be that the patients, 10% of patients have a liver disease, right? So probability of A would be 0.10, right? Then we have a second probability that whatever the patients that we have, 5% of them are alcoholic, right? So probability of B would be that patients are alcoholic. So probability of B would be 0.05. Then what happens is that probability of B by A, right? Now probability of B by A says that means that uh, patients are alcoholic given that uh, they have a liver disease, right? So probability of that particular probability would be, let's say, 7%, right? So given these three probabilities, we can calculate that if we have if we have a patient who is alcoholic, right, might not be whether like for example, yeah. So how to explain that probability of A by B is that probability of A multiplied by probability of B by A divided by probability of B. So probability of A is the prior probability, which means that a patient has a liver disease, right? Then probability of B is that patient is an alcoholic, right? Then probability of B by A is that the patient is alcoholic, that given that a he has a liver disease. So probability of A by B would be that a patient has a liver disease, but he's not an alcoholic, right? So this is how we this is used. This is a Bayes theorem basically, right? Then we have central tendency, right, in which we have mean, median, and mode. So mean is if we have a data set, so the average of the data set is called the mean. Median is the middle value of the order data set. So if we have a data set, whatever the middle value would be, it's called the median, right? Then we have a mode. So the most frequent value in the data set is called the mode. And if the data have multiple values that occur the most frequently, we have a multimodal distribution, right? So if in a particular data set we have a particular value which is occurring the most number of times, in that case that is the mode, right? So I hope till this part it is clear. Now coming up to our next slide, which is variability. So we have range. First is range. The difference, so the difference between the, if we have a data set, right? So the difference between the highest and the lowest value in the data set is called the range, right? We can have from 10 to 80 range, right? This is what we call the range, the difference between the highest value and the lowest value in the data set. Then we have a percentile. So a percentile, it's a value that indicates whether there is a value below which has a given percentage of observations in a group of observation false. Let's understand this using an example. So percentile is nothing. For example, if you have scored, it's a basically, yeah. So if you have scored 67 out of 90 in a test, now that particular score won't matter. It won't hold any value unless you know in what percentile you fall into, right? So it is a value within which a percentage of observations in a group, percentage of observation falls, right? So if you have 90th of the percentile, that means that you have performed better than 90% of the percentile, 90% of the people who took that particular test, right? Or if you fall into 70th percentile, that means you have performed better than 70% of the people who have given the test, right? So percentile is nothing, it's a value which indicates that in a certain observation, in a certain observation, in a group of observation, that particular percentage falls. So if you have scored 70 out of 90, right, and you fall into 80th percentile, so that means you have performed better than 80% of the people who have, that is the people, that means that is the group of observation, the people who have given the test. So 80, you have performed better than the 80% of the uh, people who have given the test, right? Then we have quantiles. So values that divide the number of, so quantiles are nothing but that if we have a number of data points, right, we divide those data points into four or less equal parts. That means the quantiles are quarters which gets divided into equal parts, right? Then we have interquartile range. Now interquartile range is nothing, like as I explained, range. So a range is a measure of what is the where the beginning and end is, right, in the data set. But a interquartile range tells us that it's a measure of where the bulk of the values are present in a data set, right? So it's a, basically it's a measure of where the middle 50 in a data set. So what happens is that uh, we can say that in interquartile, what range formula is that the first quartile is subtracted from the third quartile. So if we have a data set, it gets divided into three quarters, into three quartiles, right? And the first quartile is subtracted from the third, yeah, from the third quartile. So IQR is equal to Q3 minus Q1. So the range, the basic difference is that the range will tell you the where a range will basically tell you where the beginning and the end of the data set is. But interquartile range, it gives you more precision value. It gives you where the maximum, like where the bulk of the values lie in a data set, right? So that is why they prefer most of the we prefer interquartile range rather than range. Then coming to a relationship between variables. Now, relationship between variables. So we have covariance and we have correlation. So the difference between the two is that covariance tells us how the two, covariance is like how the two variables differ from each other, whereas correlation is nothing but it tells us how how the two or more variables are, many variables are related to each other, right? So first let's understand what is a covariance. So it is a statistical form that refers to a systematic relationship between two random variables, right, in which a change in the other, if one particular random variable has a particular change, it might affect the other variable as well, right? So it can, the covariance value, it can range from minus infinity to plus infinity, right? With a negative value indicating a negative relationship and a positive value indicating a positive relationship, right? And you can see the formula as well, right? That xi minus mean of xi is nothing but the data value of x, and y is the data value of y. So data x minus mean of x and y minus mean of y, right? And n is the number of data values. right? So I hope covariance is clear. Then we have correlation. So a correlation is a measure that determines the degree to which two or more random variables move in a sequence. So what happens is covariance is that they tell you, like, if there is a change in one random variable, there it might affect the other variable as well. But correlation tells us that it determines the degree to which they both are related, that they move in a sequence, right? So when an equivalent movement of another variable reciprocates the movement of one, so they are related, right? So they move in a sequence, right? So if what happens is that when an equivalent movement of another variable, or one variable, it reciprocates the movement of one variable, like there are two variables, right? So in this, uh, what happens is that, so they move in a sequence, right? So how many sequence we measure, like in what sequence do they move, and that is on terms of that we say that the variables are said to be correlated, right? So the formula is of correlation is that uh, we have covariance divided by standard deviation of x and standard deviation of y, right? So positive correlation occurs when two variables move in the same direction, right? And if the variables move in opposite direction, that is said to be negatively correlated. So correlation is nothing but it is said that one or two random variables, they move in a sequence. Either it can be same sequence or it can be an opposite sequence, right? So I hope correlation is clear. And it can differ from a range to -1 to 1, right? Then we have probability distribution. So probability distribution, it is nothing but we have probability mass function, we have probability density function, and we have cumulative density function. So first we need to understand what is a random variable. So random variable are nothing, is a variable whose value is unknown to the function. Like for example, when we throw a dice, right? The variable value depends upon the outcome, right? So there are two types of random variables. We have continuous random variable and discrete random variable, right? So now a continuous random variable, what it does is it has a values between an interval, like between a range, and it can take infinite number of possible number of values, right? So that is continuous random variable. Or we can say that whose values are obtained by measuring, uh, for example, let's say average height of 100 people, or measurement of rainfall. So we measure it, right? So that is called a continuous random variable. Then we have a discrete random variable, which means a variable which takes countable. In that we take infinite. In continuous we take infinite number of values, but in discrete random variable we take only countable number of distinct values, right? Like for example, so in the difference between continuous and discrete is that in continuous we measure the values, right? But in discrete, what we do, we count the values. So for example, we can say number of students present in a class, we'll count it, right? We won't measure them. But in the height, if you want to calculate the average height of the class, of the people or the students, we can say, so that we will do by measuring. So that is the difference between continuous and discrete random variable, right? Now let's understand what is probability density function, right? So it is a statistical term that describes the probability distribution of continuous random variable, right? So what it does is, it is the formula for that is that, not the formula, but probability distribution function for continuous data, where the value at any given sample can be interpreted as providing a relative likelihood that the value of the random variable would equal that sample, right? So it's a statistical term that describes the probability distribution of continuous random variable, right? Then we have probability mass function. So it is a statistical term which describes the probability distribution of discrete random variable, right? So this is the difference between PDF and PMF. Then we have cumulative distribution function. So it's a way to describe distribution, but it's only applicable for discrete random variables. So a cumulative distributive function is applicable for describing the distribution of random variable, either it is continuous or discrete, right? For example, if x is the height of a person selected at random, right? If we want to select x is the height of a person selected at random, then fx is going to the chance that the person will be shorter than x, right? Now if uh, f is equal to 0.8, then there is a 80% chance that a person selected at random experiment will be shorter than 180 centimeter, right? And 20%, the remaining 20% will be that they will be taller than 180 centimeter, right? Now, so this is what probability mass function, density function, and cumulative density function is. So uh, as we discussed cumulative density function example, for probability mass function, we can say that, for example, when you throw a dice, right? So it is used for discrete numbers, and with discrete numbers you can count, right? You can only count. So when you throw a dice, right, you can only select numbers from 1 to 6, so it is countable, right? On the other hand, when it comes to probability density function, you can say that, as we discussed, that when you have to measure the height of the class, or when you want to measure the rainfall or anything, when you want to measure things, in that case probability density function is used, right? Now coming to hypothesis testing and statistical significance. So we'll understand this null hypothesis and alternative hypothesis. So a null hypothesis, it's a general statement which says that there is no relationship between two measured phenomena, or we can say no association among groups. That means there is no relationship between variables, right? But an alternative hypothesis says, which it is contrary to the null hypothesis, meaning it says that there is a relationship among two measured phenomena, or among there is certain association among the groups, right? So this is alternative hypothesis. Null hypothesis says that there is no relationship among the group, while the null hypothesis says that there is no association among the groups, while alternative hypothesis on the contrary says that there is a specific relationship among the groups, right? So now in statistical hypothesis testing, a type 1, we have two types of error, type 1 error and type 2 error. So type 1 error is the rejection of true null hypothesis. So type 1 error means that we found out that there is a relationship among two measured phenomena, or association among the groups. That means we have rejected the null hypothesis, right? So we have proved that there is a relationship between uh, two measured phenomena, right? While a type 2 error is the non-rejection of false null hypothesis. That means we failed to reject the null hypothesis. That means we could not prove that there is no relationship between, we could not prove that there is a relationship among the two phenomena, right? So type 1 error means that we rejected the null hypothesis. That means we proved that there is a relationship among two phenomena. But a type 2 error means that we failed to reject the null hypothesis, meaning that we failed to prove that there is a relationship between two measured phenomena, right? Now comes the p-value. So when we talk about null hypothesis, we are talking about significance. So significance means that if we want to reject the null hypothesis, we need to prove its significance, right? So that we do using a probability value. So now, in this case, the null hypothesis said that there is no relationship between two measured phenomena, right? And the alternate hypothesis said that there is a relationship between the two phenomena. So that we calculate the probability. So we calculate the probability that there is a relationship between two phenomena happening, right? So if the probability value is greater than a certain number, so we can say 0.5, or so that in that case, if it's greater than 0.5, then we have failed to, so uh, that means we failed to reject the null hypothesis. And if the p value is less than equal to a certain value, the probability. So in that case, we reject the null hypothesis and we conclude that we have a significant result. That means that if we have a probability that there is a relationship among two phenomena, then if the probability value is greater than the probability, in that case we just fail to reject. That means we could not prove that there is a relationship between the phenomena. But if the probability value is less than the probability value is less than a certain number, then we reject the null hypothesis. That means we could prove that there is a relationship between the between the phenomena, right? So the probability of the test statistic being at least as extreme as the one observed, given that the null hypothesis is true, right? So the alpha here is the significance, right? Now comes to the regression. So a regression is a statistical model. It tells us a relationship between a dependent variable and a no, independent variable, right? So in the x-axis, it's the independent variable, and the y-axis is the dependent variable. So it is used to predict the value of the dependent variable based on the value of the independent variable, right? As you can see in the graph, the red indicates the data points and blue is the line of regression, right? So there are many types of regression algorithms. We have linear regression, logistic regression, and non-linear regression. And regression analysis is widely used in tools in various fields like economics, finance, and data science to understand and make predictions about complex phenomena. So what do we do basically? We find out the relationship between a dependent variable and an independent variable using the line equation, which is y is equal to mx plus c. So what we do, y is the independent variable, right? And x is the dependent variable. So we find out the value of the dependent variable. Sorry, y is the dependent variable and x is the independent variable, right? So I hope regression is clear. Thanks for watching.